Question number 32 of IIT JAM Economics 2021 paper. Let's see what the question is saying. There are two firms in an oligopolistic industry competing in prices and selling a homogeneous product. Please remember, whenever firms are dealing in industries which are, in prices, the only solution which is possible is that they must charge same price. The only Nash equilibrium possible. See here, I'll give you an example why. So consider the quantity. Let's just take the question a little later, but let's just see this. Consider this quantity. What's the quantity function given? 100 minus pi if pi is less than pj, 0 if pi is greater than pj. So imagine if price of firm 1 is less than price of firm 2. Quantity of firm 1 will be what? 100 minus p1, because his price is less than the price of firm 2. This is what I'm assuming. But in that case, what will be quantity of firm 2? 0. If his price is more than the price of firm 1, then firm 2 would be able to sell 0 units. This is what this says. That whichever firm has a higher price sells 0 unit. When firm 2 will sell 0 unit, it will always have an incentive to deviate. Always incentive to deviate, isn't it? So when firm 1 will have 0 as 0 quantity, because its price is more, it will have an incentive to deviate. It will lower down its price as long as its price becomes equal to the price of firm 1. So therefore, the only possible thing that can be done in this case is that both firms will charge the same price. Ideally, we proved in the Bertrand model that because both firms want to charge the same price, the price keeps on falling as long as the price becomes equal to the marginal cost of the firms. Right? So both firms will charge the same price equal to the marginal cost. And whenever the price will be more than marginal cost, they will always have an incentive to deviate. But let us go through this question and see what comes as Nash equilibrium. Let's consider first point. Point first is saying that price charged by firm 1 is 10, price charged by firm 2 is 10. What is the cost function given to us? Firm 1 has a cost equal to 10 QI. Firm 2 also has a cost equal to 10 QI. Right? So, firm 1's cost can be 10 Q1 and firm's 2's cost can be 10 Q2. Okay. What is the marginal cost? Marginal cost is 10 for firm 1. What is this? This is nothing but how cost changes when output changes. What is marginal cost of firm 2? How cost changes when output changes. This is also 10. Now imagine the cost of producing an additional unit is 10 for both the firms. The price that firm 1 charges is 10. The price that firm 2 charges is also 10. Do these firms have an incentive to deviate? That's the question we are asking. Do they have incentive to deviate? Well, deviation can be what? Either they can charge a price more than 10 or they can lower a price further. I'll just talk about firm 1. Then we will argue the same for firm 2. So, currently firm 1 is charging 10 rupees and firm 2 is also charging 10 rupees. Incentive to deviate would mean the following, that firm 1 will want to charge a lower than 10 or higher than 10. If it charges higher than 10, suppose firm 1 charges 11. Notice here, they can only take integer values. So you cannot have prices as 10.1, 10.2, 10.3. That cannot be the case. So let's say that firm 1 deviates and firm 1 starts charging 11 rupees. And let's say that firm 2, whenever you talk about incentive to deviate, you make sure that you hold firm 2's action constant. So firm 2 is still charging 10 rupees. Firm 1 has deviated and started charging 11. If firm 1 deviates to charge 11, when firm 2 is charging 10, then firm 1 will lose the market and will sell 0 units. Because this is what my function says, that the moment your price is more than the other firm, you will sell 0 units. 0 units means 0 revenue. There is no reason why you should do that. So you don't have an incentive to deviate. What if you lower the price below 10? Well, your marginal cost is 10 rupee per unit. You are incurring 10 rupees for every unit that you produce. You cannot sell lower than 10. You will be in a loss. So you cannot reduce your price to 9. You can't do that. You can't lower it below 10. So firm 1 does not have an incentive to deviate. It does not want to lower its price below 10. It does not want to increase its price above 10, given firm 2 is charging 10 rupees. Can you argue similarly for firm 2 also? Yes. If firm 1 charges 10 rupee, does firm 2 have incentive to deviate? You always charge, hold others strategy constant. Okay. So if it charges above 10 rupees, it loses the market. If it charges below 10 rupees, it is in loss. So no. So given the strategies of one firm, the other firm does not have incentive to deviate, which means that this is a Nash equilibrium. And we proved this in our Bertrand model. Remember that the Nash equilibrium which is possible is where Pi is equal to Pj. Both firms will charge the same price and they will charge price equal to marginal cost. We proved this. Now, consider P1 equal to P2 equal to 12. So this is correct. This is Nash. So let's consider that P1 is equal to P2 is equal to 12. Now I will ask you the same question. Holding firm 2's strategy constant at 12, that he's charging a price worth 12 rupees, does firm 1 have incentive to deviate? Well, if it wants to deviate, it can do two things. Either increase the price above 12, currently it is charging 12, either increase it above 12 or decrease it below 12. If it goes to 13, it loses the market. Because if your price is more than your competitor, you sell 0 units. It will not deviate here. But if it charges a lower price, it will get entire market. Because other firm will be charging 12 rupees and you have an incentive to deviate and charge 11 rupees and get the entire market to yourself. You will still be in profit because your marginal cost is 10 rupees. So yes, firm 1 will have incentive to deviate. You can prove same for firm 2 also. So because firm has an incentive to deviate, this is not Nash. So no. In fact, we proved that any other price will not be Nash. But here they have just done a tricky thing. I'll just show you what that is. Now let's take the third case. P1 is equal to P2 is equal to 40. So both firms are charging the same price equal to 40. I asked the same question. Firm 2 is going to hold the price as 40. Does firm 1 have an incentive to deviate? Let's ask. Incentive to deviate means two things. Either lower the price above 40 or increase the price above 40. You don't want to increase the price, you will lose the market. But do you want to lower the price? Definitely. I will charge a price equal to 39 and I will get the entire market to myself. So yes, I will be in super profit. So I will have incentive to deviate. If any firm has incentive to deviate, it is not Nash. So this is also not Nash. Now comes the last case. P1 equal to P2 equal to 11. Let's consider this. This is interesting here. P1 equal to P2 equal to 11. I will hold the strategy of firm 2 at 11 and ask the same question. For firm 1, should firm 1 increase above 11? No. It will lose the market to its competitor. So above 11 is wrong. You cannot do that. But can you go below 11? Well, because price can only take integer value, going below 11 would mean that you will go to 10. In case you go to 10, you will get entire market. No doubt in that. It's a very good proposition that lower your price to 10 and get entire market. But let's just think for a while here in this case. In this case, when you lower your price to 10, your price is exactly equal to marginal cost. So your profit will be 0 because price is equal to cost. So you are going to make no profit. Whereas when you were charging a price equal to 11, you were getting half market. And at the same time, you were making profits because price was above marginal cost. So P minus MC was 1 rupee. So you had a markup. Your price was above marginal cost. So here, when you lower your price, because lowering it by 1 rupee would mean equal to the marginal cost, and equal to marginal cost would mean that no profit. No doubt you will get entire market. No doubt. If I look at my function, I will get this market. How much? 100 minus P1. This will be my quantity. So in this case, when price is 10, you get the entire market, 100 minus P1. So Q1 was 100 minus P1. So you will sell 90 units, but you will make no profit because P1 will be equal to MC. When price is 11 rupees, you will share the market half. So your quantity will be 100 minus P1 by 2, right? So it will be 100 minus 11 by 2, which is going to be 89 by 2. So each of the firm would be selling 44.5 units. But at least per unit, you will be making a profit of 1 rupee. So then, in this case, the firm will think that I am profit maximizing. Why should I reduce my price from 11 to 10 and gain no profit at all? Sell 90 units, but no unit at profit at all. So this is very interesting case. Here, the firms, even at price, when both the prices are at 11, the firm will not have an incentive to reduce the price to 10 because it will not make profit at 10, and at 11 it is making profit. unlike the other cases. So you would say, why not? Why didn't we use the same thing here? Because in all other cases, when the two prices were equal, when P1 was equal to P2 was equal to 12, reducing the price by 1 still gave you profit, but entire market also. Reducing the price by 1 from 40 to 39 gave you profit plus entire market also. But in this case, when you reduce the price from 11 to 10, it gives you no profit, only market. You sell it to the entire market, but you don't sell it at a profit, right? You're selling it at marginal cost. So what do we conclude? And this is very important for a Bertrand model. See, in Bertrand model, the case that we did was always when prices were continuous. We always assumed price as a continuous function. So when prices are continuous, the only Nash equilibrium that can exist in that case is when prices are equal, but they're equal to the marginal cost. This is the only Nash. Why? Because in this case, when price is a continuous function, let's say that prices are kept equal. Suppose marginal cost is 10 and both of them are charging 11 rupees. Then one firm may still have an incentive to deviate and may think that let me charge 10.9 and get entire market of 90 units and make a profit of 0.9 per unit. Are you getting it? Firms will have incentive to deviate from 11, charge a price lower than 11, but greater than marginal cost. So then this other firm will try to cut it down and bring the price to 10.8. This firm will want to bring it to 10.7. So they will always keep cutting down each other. So when prices are continuous, the only Nash possible is Pi equal to Pj is equal to MC. But here in the exam, they gave this trick that prices are integers. So when you cut down the prices, you have to cut down by entire one. Whenever prices are integers, there exists two Nash. One is where Pi is equal to Pj is equal to marginal cost. This is definitely Nash. No one has incentive to deviate. We proved it. No one deviates. You can't lower it further. Even if you increase it, you will lose the market. No incentive to deviate. The other equilibrium is Pi is equal to Pj is equal to MC plus 1. If both the firms charge exactly the same price, equal to marginal cost plus 1 rupee, then also they will not have incentive to deviate. Not deviate. Because if they lower their price by 1 rupee, it's in integers. So either you lower by 1 or you increase by 1. If you lower it further, then you will be charging price equal to MC and you will make no profit. Currently, you are making profit. And if you increase it, you will lose market. So in this case, if this is struck, both charging equal to MC plus 1, no one will deviate. Because at this price, you will be sharing the market but making profit. If you lower the price, you can only lower it by 1. Unlike continuous cases where you can reduce it by fraction and still have a chance of getting the entire market. So you will keep deviating from MC plus 1 equilibrium. Here you will not do that. Here MC plus 1 will become a Nash. So you have to remember this thing. In Bertrand model with prices being integer, even MC plus 1, if both the prices are equal and equal to marginal cost plus 1, then this is in fact a Nash equilibrium. No firm will deviate from this. So what have we got? The answer to this is A and D. Both of them marginal cost and marginal cost plus 1 are in fact Nash equilibrium in this economy. Okay, thank you.